So let's say we have xenon tetraoxide. So how would I draw the Lewis structure for this compound?
It would be in the middle, and then you'd surround it with 3 of the oxygens.
Okay. So you said xenon would be in the middle.
Right.
Okay. And how many valence electrons does xenon have?
8.
It has 8.
And if I recall correctly, oxygen has 6 valence electrons.
Okay, so each oxygen has 6 valence electrons. So we have 8 plus 6 times 3.
$26.
Okay. So 26 electrons. So how can I arrange this so that everybody's going to be happy?
Probably either using a single or double bond somewhere.
Oh, do I have it already? So you're saying just make the lines.
Oh, well, I suppose, yeah, making the lines would help.
Okay. So you're saying, oops. Is that what you're suggesting?
Yes, for now.
Okay. But that's what you're suggesting online, right? I mean.
Yeah, at least just draw the lines.
Okay. So then that's 2, that's 4, that's 6, that's 8, that's 10, 12, 14, 16, 18, 20, 22, 24, 26. So all 26 are accounted for. So that's 8 around this oxygen, 2, 4, 6, 8. 8 around this oxygen, 2, 4, 6, 8. 8 around this oxygen, 2, 4, 6, 8. And 8 around xenon, 2, 4, 6, 8. Everybody's happy.
Mhm.
Are you good, Lucy? Can you hear me now?
Yeah, my volume was off.
Okay.
Sorry.
No worries. It happens to the best of us. So usually I will actually give a whole lecture and not turn on, I'll keep it on mute. And then people are like, I have 50 messages. I'm like, oh, I guess they were trying to say something, right? Okay, so pretty simple, right? So you guys want to be familiar with this because you know you're going to see this on the exam, right? This definitely will be on the exam.
Mhm.
Okay. Okay, so let's talk about the exam. I've had some trouble with your exam. The question pools were not linked correctly. And so Harnell, you guys, your questions will be fixed later on tonight when I get a chance to relink all of the question pools. Your questions should be okay. Same thing happened initially, but I was able to catch it before it went live and or before you guys really started answering questions. There's a couple of you guys that kind of beat me to the punch, but we kind of worked around it. So it should be working fine. If you have any questions, if something happens on your practice test or something like that, let me know, because we've had a little issues with Canvas these last couple of days. And so Harnell, I need to relink yours. Yours should be up and running after this class. So I should have it all together at that point. Okay. So what does that mean for you guys? That means you guys get an extra day. Okay, so it's not going to be due on Sunday at 11:59. Instead, it's going to be due on Monday at 11:59. Okay, so that doesn't mean that you wait till 11:58 to get started. Okay, I'm not looking at anybody in particular, or call me. Dr. Henry, I can't get Proctorial to work. Okay, so also make sure that you guys read the instructions. I've given you every possibility that I could think of and an answer for every possibility. So there's a video for everything that could go wrong with Proctorial, pretty much. Okay, if you happen to get locked out, which does happen. So like I had one instance where a mom, her daughter came in screaming and hollering and jumping all over her. And then what happens is that the program picks it up. And if it happens too frequently, the program will actually shut off and say you're locked out. If something like that happens, let me know. Then I'll take a look at your video, see if it's cool, and then I will try to reset it for you. Unfortunately, sometimes that means that you may have to retake the test. And so, you know, the best thing to do is try to get yourself in a situation where you're in a quiet place, you know, and make sure you have that block of time quiet. Nobody's coming in and bothering you, because it's really shitty when you get down to like, you know, you're down to that last question you need to be answered and you get locked out, you know? So.
Dr. Henry?
Yes.
So for Hartnell, it's due on Sunday?
No, it's also going to be due on Monday at 11:59 p.m.
Okay,
You guys will have until Monday to get it done.
okay, thank you.
Okay, questions? So I believe the tutors are going to be having reviews this week, right? And I will give them a practice test to work off of. So technically they can get their own practice test, but I'll show them how to do it. Okay, so you want to let them know when you guys are going to have a review? Okay, is it also going to be available online? Okay, so have a Zoom at the same time. Okay, so the review will be Thursday, 4 to 5, and you'll give me the Zoom link because you may have some students from Hartnell that are interested as well. Okay, good. Okay, questions?
I have
Yes.
a question. So the exam is only on 2, 3, 5, 6, 11, 12, and 13?
Yes, and 8, part of 8, because you guys know how to balance chemical equations.
And 8.
So I'll repeat that. So the exam will be covering chapters 2, 3, 5, 6, 11, 12, 13, and oh, actually it's a little bit of 8 and a little bit of 21.
Okay.
All right. So what we'll be going over today? Jump right on the board. Hey, it's chemistry. You've been learning this from everything you learned from the beginning to everything you learned from the end. Everything is fair game, right? You got it? But you will, right?
Are we going over balancing equations today?
No, we've gone over balancing chemical equations. If you have a question, I will do a question. We went over it the very first lecture. We started going over balancing chemical equations.
The very first lecture,
Yes, the very, very first lecture.
which was chapter 2.
Chapter 2, yes. So let me give you an example. Can I put my board here?
Oh, that's right.
Okay, so if we wanted to balance this chemical equation, where would we start?
By writing down the different elements.
Okay, so we're gonna write down the different elements. So we have a carbon, we have hydrogen, and we have oxygen. Okay, so on the reactant side, how many carbons do we have?
1,
How many hydrogens do we have?
4,
How many oxygens? You said 2.
2,
Okay. On the product side, how many carbons?
1,
How many oxygens?
3,
How many hydrogens?
2,
I was just keeping you on your toes. Okay, so is it balanced?
no.
Okay, what do I need to do to balance it?
Multiply the um, hydrogen in the, not the reactant side, the other one,
On the product side,
product side,
okay, so we're going to put a coefficient in front of,
H.
okay, so we're putting a coefficient of 2 in front of the H.
Mhm.
So then that gives me
4,
4 hydrogens. How many oxygens?
5,
So I have 2 here plus 2 times 1.
4.
2 times 1. 2 times 1 is 2, right?
Mhm.
Plus 2, right? Okay. So you guys got to remember, what if this is a coefficient, I need to multiply it by that entire thing, right? Okay. So then that gives me a total of 4, right?
Mhm.
2 plus 2 is 4. Okay. So everything's balanced except for my oxygen. So how do I balance that out?
Multiply by 2. So you put a 2
To where?
on the reactant side,
In front of what?
oxygen.
Okay, in front of oxygen gas. Okay, you guys see that? Yes, you had a question. Because we need to balance out the 4 oxygens on the product side, right? So the only way that we can do that is by putting a coefficient in front of that oxygen, right? So if we put a 2 in front of there, so that's 2 times 2, doesn't that equal 4? So that's where the 4 comes from.
That's the law of
Conservation. So on the
conservation.
other side,
Okay.
here we have 4 hydrogens that we're starting off with over here, right? So initially we have 2. So if we put a coefficient and 2 in front of here, so that's 2 times 2, right? Because yeah, exactly, that's 4, right? So that's where we got the 4 from. Yeah. So you got to remember the coefficient is for the whole molecule, right? It's not just for that one that is next to, it's for the whole molecule. So the number that's in front is for the whole thing, right? So it's for both of those elements because they're acting together as a unit, right? Okay.
And the coefficients are whole numbers, and that's the law of proportionality.
No, the law of proportionality basically refers to the element itself, right? Or the compound itself. So for instance, if we're talking about CO versus CO2, right? Both of them have carbon and oxygen, right? But this is a 1-to-1 ratio of carbon to oxygen, where this guy is a 1-to-2 ratio of carbon to oxygen, right? They're 2 different elements. They mean 2 different things. So, you could have them. So regardless of how much of this I have, I could have 50 copies of it. It's still going to be a 1-to-1 ratio, right? Where this one is always going to be a 1-to-2 ratio.
Okay,
That
got
make
it.
sense?
Yeah.
Okay. Okay. Can I clear? Okay, so let's go back to where we left off last week, where you guys went, your brains were fried, right? Pull up the chapter 13. See how much you guys remember from what we talked about. Okay, that's good. That's a good question. Very good question. Okay, so there's a question on one of the homework assignments, and I'm going to see if I can help you guys out. It's actually a very good question. Okay, so let's go back to the whiteboard. Okay, so let's say we're doing electron configuration. Yeah. And you also need to know this. So if we're doing electron configuration for Cr3+, okay, and we're going to do it the long way and we'll do it the short way. We'll do both possibilities. Okay, how many of you guys have your periodic tables available? Excellent. So let me pull up my periodic table. Then I'm gonna. Okay, so you guys see the. Okay, so we're doing electron configuration for Cr3+. Here's Cr. Okay, so what we want to do is we want to go systematically through the periodic table till we reach the chromium, right? And then we're just going to write down the electron configuration for chromium, right? And the rule is that we always take from the highest period first, right? So if we have a period of 4 and a period of 3 that's listed, then we're going to take away from 4 first, and then we'll take away from 3. Okay, so I need you guys to help me through this because I know you're a little rusty. Or am I wrong? You know, you probably got this.
Let's see.
Okay, so we have Cr3+. Well, we'll start off with Cr first. Okay, so we're going to write down the electron configuration for chromium. So we started at the very first period. So it's 1s. And how many electrons are going to be in the 1s?
2.
How many electrons are going to be in the 1s? There's going to be 2 of them. So 1s, 2. My s looks like a 5, I know. It's an s. Okay, so then that takes care of that first period. Okay, so then in the second period, it starts off with the s. So it's 2s, 2s2. So that takes care of this. Okay, and then this part over here is called the what?
P.
The P. So it's
2p
second period, 2p,
6.
and there's 6. So that's 1, 2, 3, 4, 5, 6. Okay, and then we have
3s.
third period. So 3, 3s2. Okay, so that takes care of here. And then over here,
3p6.
3p6. Okay, so that takes care of this. And then we have
4s2.
for S2. So that's right here. And then chromium is,
3d4.
right? So it's 3D4.
Now, there are 8 in the D block, right? 1, 2, 3, 4,
No, there's 10 in the D block.
or 10.
That's right.
So-
There's up to 10, yeah.
There's the sharing issue. I just forget the rule.
There's no sharing issue right now, right? Because there's
Okay.
no sharing that's going on here, right? We're just talking about a single element and by itself. So there's no sharing that's going on.
Oh,
So-
okay. I thought the D block wanted to take from the S4, 3D wanted to take from 4S2.
It doesn't share, it levels. It's a little bit different. And
Okay.
for this class, you don't have to worry about that. So there are quote exceptions. So in this case, they would actually take one electron from the 4s to level it off so that it would be halfway full, right? That's what it would do, okay, for chromium. But regardless, you're going to end up with the same outcome in this case. And for this class, I don't want you to worry about that. I want you just to be able to use the periodic table to get to that point. And then when you get into one and general chemistry, then we'll get into that detail. Okay. Okay, so when we're removing, we're going to remove from the highest period. What is the highest period? I see.
4s2.
Or S2. So we're going to start from moving from there. So we're taking a total of 3 electrons away because it's 3 plus. So if we do Cr 3 plus, so we have 1s2, 2s2, 2p6, 3s2, 3p6, and then we're taking away from here. So we're removing 2 here. So we're removing both of those. So there's not going to be any 4s. And we're going to subtract 1 from here. So then what's going to be the final outcome?
The same, but at the end it's 3d3.
3d3 with no 4s, right?
Mhm. And
Okay.
then to do the brackets.
So using the bracket method the other way. So to do it the other way, the short way, you would take the the noble gas that would be right before chromium, which is argon.
Mhm,
So then we just put argon in brackets.
mhm. And then you would start at 3d3.
3d3. That's right. And that's it. Okay. Does that help? Okay. You also have a question on your exam that is this as well. Or a couple of questions. AR because it's the nearest total gas, and so you're saying that by using the AR, you're saying that all of the electrons there are full electrons, meaning that they're not going to be at their kind of stored, they're protected, you're not messing. Okay.
Dr. Henry?
Yes,
So the CR, the first one we did, that was from the ground state.
that's right.
And then the one where we started at the noble gas, is that the noble state or the noble ground?
So no, it's still considered, so this guy is ground state right
Yes.
here. The difference is by it being 3+, we're just talking about the ion, but it's also ground state. It's just two different ways of writing it. This way saves us time,
Mhm.
and it also helps us realize which electrons are available for bonding. That
Yes.
can be used for bonding.
Mhm. But what's the term used for when you start at that noble gas? Isn't there
That's the core. So you're starting off with a core.
a core? Okay.
So yeah, this is called the core. Okay. Questions? Okay, good. Okay, so let's go ahead and get started. So I have a few questions for you. If I can get my lecture notes up. Organic. What does organic mean?
Carbon.
Primarily, it deals with chemistry that deals with carbon, right? Organic chemistry is chemistry that has carbon in it, essentially. Okay. Okay, so we've talked about alkanes. Oh, yes, you got a question? Oh, you didn't get a packet. Do we have any more chapter 13? Okay. Alkanes, alkenes, and alkynes. What is the difference?
Bonds.
Bonds, okay? So specifically, alkanes, how many bonds?
Single.
Single.
They're all single bonds. Alkenes,
Double.
okay, double bonds. At least one double bond. And then alkynes.
Triple bond.
Okay. So, do you guys remember how to name them?
Do you start with the longest chain of carbons?
You always start with the longest chain of carbons. So let's say we started off with this guy. How many carbons do I have?
1, 2, 3, 4, 5.
5 carbons. So let's write it down so you guys can see it. So that's 1, 2, 3, 4, 5. Okay. So 5 carbon chain. I heard somebody say it. I know I'm not deaf. 5 carbons. Pentane.
Pentacarbon.
And 10.
Oh, okay. Pentane. Okay.
Okay. So what if I had something like this?
It would be heptenes,
Heptene. Is that it?
and then you have a double bond at the 2, so it'd be 2 dash heptene.
2-heptene. Okay, since it's a double bond, it's going to end with E and E. And we want to give the substituent or the structure the lowest number possible. So we want to count from the side that's going to give it the lowest number possible. So if we started counting from side here, 1, 2, 3, 4, 5, 6, 7. So we start, in this case, from the right-hand side, 1, 2, 3, rather than starting from the left-hand side, which would give it a much higher number. I believe it's 5. So we want to try to make sure that we give it the lowest number possible. Okay. You guys are good? Sorry.
I would go for the same for the triple bond, right?
Okay. Okay, so let's try one more. Because I know this is all review, right? So let's say we have don't get so excited. Okay, something like this.
Would it be 9 carbons?
Okay, so let's count the carbon chain. So you're saying 9. Okay. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So what's next?
So
It has triple bonds.
Right, I'm a little bit confused as to the drawing itself.
Okay.
So I didn't catch that there was a it was 1, 2, 3. I just went one I traveled.
Okay. So let me see if I can help you clarify it a little bit. Get another color. Okay. So we have one that will start here. The triple bond, because the triple bond can't do a kink. It has to be linear, right? Because it doesn't have that ability to kink, unlike the double bond and the single bond. So triple bond has to be straight. So it will be attached here and it will be attached there, right? Because we know that it looks like this. C, triple bond, C, and then in this case, we are attached to another C. So that's 1, 2, 3, 4. Carbon could have 4 bonds or 4 attachments, right? So it could have 4 individual attachments or 4 lines. That's it. So on the other side, it's going to be the same thing, another C. So this is going to be a linear structure, right? You guys see that? Okay. So that's the reason why it has to be straight. Okay. So here, my 4 looks like a 9, doesn't it? It's a 4. Okay. So this is going to be exactly the same thing, right? So when we do the counting, this is going to be 1, this is going to be 2. So that's going to be that first carbon, this is that second carbon. Okay. This is the third carbon after the triple bond. Okay. Then we have the fourth carbon after that one. Then we have another triple bond. You guys mind if I erase this and drag it over so you guys can see?
And we only know that 2 is there because carbon can only have 4 attachments.
That's right. So you need to remember that when you're looking at, because you think about it, it's octet, right? That means it only can have at most 8 around it. It obeys the octet rule all the time. Okay, so that's the reason why it's important that we understand octet. Yeah, total of 8 electrons around it, right? Which means that if it's 8 electrons and electrons pair up, right? So then that means how many pairs of electrons can you have around you? Or how many bonds can you have around you at most? 4, right? Yeah, we've talked about those exceptions, but carbon is not one of them. Carbon will only have 4, and that's it. At most. Well, we did talk about those exceptions in this class, but we talked about it. We didn't press on them too much. Okay, so back to this. Let's focus on this. Okay, so, and we can talk about that here afterwards. Okay, so now we have carbon in this a nice linear structure, right? So that represents this whole line right here. So that would be the 6th carbon, right? So then we can start getting kinky again, right? So then we can put a carbon up here for the 7, and we can put a carbon down here for the 8. So 7 and 8. And then 9. My C's are horrible too. Okay, now we know that since these are single bonds, they have to be saturated with hydrogens because it's a hydrocarbon. We know that these are going to be hydrogens. So hydrogens are going to be bonded to those carbons. There's going to be 2 here, there's going to be 2 here. To add up to that 4 bond, right? So that's 1, 2, 3, 4 around here. That's 1, 2, 3, 4 around here. Okay. So this here is called the expanded structure. This here is called the skeletal structure, right? Can you see why I like drawing the skeletal structure compared to the expanded structure? You don't know why? Oh, okay. Okay, so we know that our longest chain is 9 carbons long, right? So 9 carbons, what is the prefix for 9?
Non.
Okay, so we have nona, and we know that it has triple bonds, but there are 2 sets of triple bonds. How do I dictate that there are 2 sets of triple bonds? Okay, so I say where they're at. Okay, so we start on the 2nd carbon and we start on the 4th carbon. So it's 2, 4. Okay, and it's nona. Anything else? How do I signify that there's 2, right? I need to let them know that I have 2, not only where they're located, but I need to say I have 2 of these. Di, that's right, di. And since it's triple bond, ine. Right? So it's 2, 4, nona, diine. Okay, I know you guys can't see it in the back. Does this help if it's up here? Yeah, that helps. My head is in.
Dr. Henry? For the dye,
That's right.
it goes
Oh.
in the middle. It doesn't go before the nona.
No, it goes in the middle where the structure is, because you're telling me that I have 2 double bond. So you want to put it right next to that structure. Okay.
Okay.
So this is one way of writing it. The other way of writing it, and most people hate the way it looks, it's not pretty, but it becomes functional. So the other way of writing it is Nona dash 2 4 dash diene. Okay.
So in the first method, it's the bond location, then the Greek prefix, then how many how many of those bonds you have, and then the type of bond at the end.
That's, well, yes. So it's the location, right? So you're telling me which carbon it's off of. It's the longest chain, what the chain is, and then where and how many of that structure we have, how many triple bonds we have. Okay. And then in the second case, it's the longest carbon chain, the location, and then the triple bonds, the quantity, and then the triple bonds. Okay. Okay, so you guys recall, we can also have side chains.
Mhm.
Okay, so when we have side chains, what we need to do is we want to find the longest chain first. So let's go ahead and find the longest chain.
Would it be 6?
So it'll be 1, 2, 3, 4, 5, 6. Okay, we want to start numbering to give our side chains the lowest number possible, right? If there is a double bond or a triple bond, it has priority over the side chains. We want to try to give the double bond or the triple bond priority. Okay. So in this case, we have 1, 2, 3, 4, 5, 6. So a 6 carbon chain is called what? Single bonds, all single bonds.
Hexane.
Hexane. Hexane. Okay. So on the second carbon, we have a methyl group because there's one carbon. So there's one methyl here and there's one methyl here, right? So then, since there's 2 methyls, we would say 2, 2 dash dimethyl. And then on the third carbon, there is an ethyl. It's 2 carbon chain, 1, 2. So then we put 3 dash ethyl. Okay, and when we do the ordering, we put them in alphabetical order. E, ethyl, comes before methyl, because alphabetically, E comes before N. Even though we have dimethyl, we look at the methyl, not the prefix. Yes. You just count, right? We're saying that on the third carbon, so this is the main chain. This here represents the main chain, right here. What's coming? On the third carbon, we have 1, 2. 2 carbons. That's enough, right? That's right. So if you guys remember, let me take a step back or a step forward. Do you mind if I flip the everybody got this down? And then we'll come back to the space because it's a good space. I'm going to clear. So if you guys remember, meth, 1 carbon. Eth, 2 carbon. Prop, 3 carbons. Bute, 4 carbons. Pent, 5 carbons. Hex, 6 carbons. Hep, 7 carbons. Oct, 8 carbons. Nona, 9 carbons. Deca, 10 carbons. Okay, so you want to know that, right? Like you want to know your Greek prefixes. What are your Greek prefixes? Mono, di, tri, tetra, hexa, penta. No, it's penta, hexa, hepta, octa, nona, deca, right? So like down here, that it's exactly the same, right? Okay. So now you'll notice bute and below, all of these guys for anes, they're gases. They're also, yeah, they're weird. They're not the normal Greek prefixes, but they're also in the gaseous form at room temperature. Okay, where pentane, hexane, heptane, octane, all of these guys are liquid forms. Okay, we'll talk about why that's the case, but you want to kind of keep that in mind too. It's their physical characteristics, right? And you guys kind of know that already, because how many of you guys smoke or pretend to smoke? Or smoke bongs or smoke wax or anything like that? Anybody do that? Nobody does that here. Okay. And I am, whew, sure you are. And my name is Fred, you know. So anyway, but if you knew that, right? So you know that, like, for instance, gasoline. Gasoline is primarily octane, right? It says octane on the side of it, right? Octane. Okay, we know that's a liquid, right? We know that butane is often in a little tube and everything like that when we fill up our lighters and stuff like that. It's butane, not to say that you guys smoke or anything like that. Okay, we grill. How many of you guys grill, right? Propane, right? We know that that's a gas. Okay, and we know that cows farting is methane, right? We also know that that's a gas, right? Okay. Okay, so let's go back to those side chains, right?
Dr. Henry, I have a question.
Yep.
If we have a double bond in there,
Mhm.
we give it priority for it to be the lowest, right?
That's right. How did you know what it was going to work on? I was just getting to that. Okay. So when we have a double bond, the double bond has priority, right? So we want to try to give the double bond encompassing in the longest chain. And then everything else is going to be a side chain. So, and we also want to try to give it the lowest number. Okay, so here, are we going to start counting from the left or the right?
Left.
Left.
Okay. So that's 1, 2, 3, 4, 5, 6. Okay, longest chain. What is the prefix for it?
Hexane. But it'll be hexene because it's double.
Hexine, since there's a double bond, okay? And where is that double bond located at?
2.
So it's 2 hexene. Okay, are there any side chains?
Yes.
Okay, tell me my side chains and where they're located.
They're located at 3
I have
4,
3
and 5.
ethane, ethyl. Okay, 3 ethyl. Okay,
And then it'd be 4, 5 di
4, 5
methyl.
Okay. Because they're side chains. You're letting me know that they're side chains. Because if you don't put a YL ending, you're assuming that they're the main chain. That's right. Yes, so when it's a side chain, they're called substitutants. When your substitutants are just hydrocarbons, you use YL at the end.
Dr. Henry, is it okay if we don't put it like in the same sentence, if we put it like on the top 3 ethyl and then 4, 5 dimethyl?
Well, you want to try to put it in the same sentence because it's a compound, if there's room for it. You know, sometimes, you know, you're typing it in and it'll kick you down to the lower level. I know what you mean, but you would normally put it in the same sentence. Yes. That is a very good question. So it depends on the textbook that you're using, right? So some textbooks will actually put dashes between them and others won't. So usually the dash are used to show what belongs to what. Okay, questions? You had a question, yes. Yep. Okay, that is a very good question. So if we take a look at the difference between 3 and 4, you get a different color. Okay, so on 3 carbon, coming off the 3 carbon, that's 1, that's 2, right? So we know that 2 carbons, F, right? The ETH. On the 4 and 5 carbon, we have just 1 carbon that's coming off. So that's meth. And think about it. Meth head is only thinking about himself. One person, meth, right? Okay. Questions? No questions? Good. Okay. Now we'll see how much else you remember. Okay, I'm gonna add another layer, see if you guys remember any of this. So, oops. Let's say I had this structure. Okay.
Is that a cycloalkane?
It is a cycloalkane. So, but what would be the name of the cycloalkane?
So it has 5 carbons.
Okay, so it's 5 carbons.
So it'd be cyclo.
So if I say cyclo.
Pentane.
Cyclopentane. That's okay. That's right, because it forms a ring structure, right? It closes in on itself. Okay, so anytime that we have a ring structure forming, all the carbons are connected, in a circle, right? Cyclo. Okay. So these are called cycloalkanes, right? But its specific name is cyclopentane because it's a 5-carbon chain. Okay. So just like the linear chain, when we have structures, we want that to have the lowest number. So let's say we have on the cycloalkane, we had a structure like this.
It'd be 1 dash cyclo.
Take a look at it now. I made a change before.
Oh, okay.
Let me finish drawing the structure. So take a look at it now. I know my head's in. Sorry. Can't help it. Now you know what? Okay, you guys got it down?
Mhm.
So again, we want to try to give it the lowest number possible, right? All of the structures on there. So if I'm giving it the lowest number possible, where should 1 be?
Where the branches?
So right here.
Yes.
Let me put this up so that you guys can see my back. I apologize. See it now? Yeah. Okay. You guys over there? You guys see it now? Can I erase this? Okay, so where should I start numbering?
Where the branch starts.
Right, where it takes up. So that's 1. Yeah, I can number, 1, 2, but no, I want to start here because it's a twofer, right? I have something coming off the first carbon. So we want to try to give things the lowest number possible, right? That's even our methyl groups. If we can make it 1, then we're going to make it 1, right? And here's the ability of making it 1 rather than starting it over here, right? Okay. So then that's 1, 2, 3, 4, 5. So that's our 5th carbon. So then what would be the name of the structure? Cyclo.
Pentine.
Cyclopentine. So where's the double bond at?
At the 1.
So it's at the 1. So 1 dash cyclopentine. Anything else?
Yeah. 1
Where's the methyl located at?
at the 1.
It's at what number? Because you have to give me its address. 1 methyl. Okay. So it's 1 methyl, 1 cyclopentine. What was that? Well, this one here, the ENE, right? That's always going to be at the end. The longest chain always gets to be at the end. So, and that's, let me elaborate a little bit. So, in life, we have things have priority, right? Like we put a good parent will put their kids before themselves, right? So their kid is a priority, right? So very similarly, in organic chemistry, there is a priority, right? So at the bottom right now, what we've talked about We have alkanes, A and E. That's the lowest priority. Then above them are the alkenes and alkynes. They're like even, right? But alkenes are a little bit better because they're more common than the alkyne, but they're considered to be even in terms of priority. So alkanes, lowest, alkenes, alkynes are kind of even right now, okay? And then the side chains, they have lower priority. So anything that has lower priority are going to be put in front. Like when we think about you, we think about you and your last name. So we'll give you your first initial, H, and is it Camacho? H Camacho, right? Well, we don't care what your real name is. We don't care the high part. You're Camacho, right? That's your priority, right? That last name. So the thing that is most important is put last. It will be put in front and put in alphabetical order, okay? Does that make sense? Okay, so you guys want to try another? Yeah, okay. Okay, so let's see if we can get started. Okay, that ring structure, what is it going to be called?
Hexine.
So it's going to be a cyclohexane.
Hexine.
Okay. E and E. Okay. So
The double bond is in one.
double bond's going to be in one. Okay.
And then you have a branch off of three.
Okay. What's coming off of the three?
3 carbons.
3 carbons. What is the 3 carbon?
Propyl.
Propyl. 3 propyl.
And then you have another branch off of 5.
Okay. So 5.
5, 5.
5, 5.
Dash dimethyl.
Dimethyl. Okay. So again, we want to try to give it the smallest number as possible, right? So if we started here, that's 1, right? So then that's 2, 3, 4, 5. We started here, that's 1, 2, 3, 4. So we want to go in this direction to give us the smallest numbers possible. Okay? Questions? Concerns? Kool-Aid? Okay. Okay, you guys ready to move forward? Or do you need time to write it down? Sorry.
Then you'll get money.
Yeah, and then I probably get fired.
Dr. Henry, on the
Yes.
on the exam, are we gonna have problems where you write out the name and then we have to draw it, or?
You're gonna have both. And so don't worry, I'm gonna give you an opportunity to go through both, but I want to introduce some more structures for you. So you need to be able to go both ways, right? Swing both ways, okay? Okay, let's go. Okay, so this is just a reminder. You guys can't see the upper part of the slide, but you always want to identify the longest chain first. Longest chain. Now, if your structure, you want to try to keep your structure in that longest chain, right? If you can. If you can't keep your structure in the longest chain, then you want to go with the longest chain with that structure. So if it has a triple bond or a double bond, you want to incorporate that triple bond or double bond, okay? And the longest chain that you can incorporate. Okay, so these guys are isomers of each other. So this guy is N-butane. This guy is isobutane. Isobutane is its common name. It's not its IUPAC name, okay? So chemistry has been around a long time, right? And so there's all of these rules that have happened well before we've made these new rules, right? IUPAC is the new naming system to try to make everything more uniform. Okay. Before that, we would go by its common name. And so we would know that this guy was isobutane because there's 1, 2, 3, 4 carbons. Iso basically means that you're isolating that center carbon. So you have a methyl group here and a methyl group here and whatever you have over here, right? So you'd have 2 methyl groups isolating a carbon, right? So then that would be considered iso, right? And again, that's its common name. You guys, for your exam, don't worry about its common name. You guys will worry about that when you guys get into organic chemistry. Right now, I just want you to know the IUPAC name. So if you know how to name it, IUPAC, you're good. If you can throw in the common name, you're great, you know? So in basically means that it's going to be in a line, right? In a line, right? In. So if it's just linear, you know, it's like carbon, 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 carbon in a line, then it's considered to be in whatever it is. So in this case, in butane. Here, this guy has, this is in pentane. Okay, or we would just call it pentane, right? This guy here is iso. Remember, a methyl group here and a methyl group here, isolating that 1 carbon. This guy is isopentane. This one here is neo. Neo because you have 4 structures around isolating that carbon, right? So that guy would be neo, right? Again, common names. These are its common names. These guys are all isomers of each other, so they have the same chemical formula, but different chemical structure, right? And you guys kind of see the distinction between them, right? They're different. They look different, right? Are you guys awake? Okay.
I'm here.
Good, good. You guys look like zombies. It's not Monday, it's Tuesday. You're supposed to be like, yeah, it's Tuesday. We're working through it. No, believe me, I'm right there with you. Okay, so far we've talked about only hydrocarbons, things that are just hydrogen and carbon. Now I'm going to start adding on some other functional groups. So this next functional group is called alkaline halides. Okay, halides. Hal, we know that hal is short for halogens, right? Who are your halogens? Bromine is one.
Group 7.
No, selenium is not one. Bromine, chlorine, fluorine, iodine, right? So those guys are your halides. Now, when we talk about priority, halides are at the bottom of the totem pole. Okay? We have alkanes that are above it, and we have alkenes and alkynes that are almost at the same level. Okay? So, since halides are at the bottom of the totem pole, they're always going to be in the front, right? Because they don't have priority. So for instance, we have this structure here, although it doesn't have all of the H's. Let me add on the H's so you'll know what you're looking at. So this guy should have H, CH3 here. 2, 3. This guy should have an H. This guy should have an H. This guy should have 2 H's. And this guy should have 3 H's. Okay. Can you guys see that? Okay. So in this case, we count our carbons as we would do normally. So that's 1, 2, 3, 4, 5. Okay. So we know on the second carbon, there's a chlorine, right? So we put just an O. We drop the I and E, and we just put an O. So it's chloro. Okay. On the third carbon, there's a bromine. So we drop the I and E, and we just put an O. So it's 3 bromo, 2 chloro, pentane. Okay. So let me show you what the structure looks like for this guy. Skeletal. This is the expanded, sort of. Skeletal is much easier to draw.
And then it's possible to have side chains, right?
Yeah, it is
Or something-
possible. Yes, you could also
Or
have
something that
methyl.
complicated.
You could have methyl groups and things like that on the slide as well too. Yes. Okay. So this is the skeletal structure of this compound. Okay. Pretty simple. Okay, so simple functional group, not too hard. So, but the key is a lot of times students will look at this and they'll see Cl and they'll say, well, this is a methyl, right? But that line represents that it's bonding to the Cl. So it's coming off of the second carbon to bond to the Cl. You guys see that? Okay, so let's see. Let's see if you guys got this. Okay. Now, we always want to go with the one who has priority, and you want to start there. Give it the lowest number, and then everybody else kind of has to deal. Okay. So who has priority?
The double bond.
Double bond. So where are we going to start counting from? The double bond.
The double bond.
Okay. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's a horrible 9. There we go. Okay. So what's our structure's name? Okay. So it's Nona,
Nonene.
Nonene. Okay. Anything I need to put in front of that?
One.
1 dash.
1 dash. Okay. What were you saying? 9 bromo. Okay. 9 dash bromo. Okay. So 6. Now there's 2 of them, right? Because there's 2 of them there. So it would be di. That's right. So it's 2. So it'll be 6, 6 dash di
Iodine.
ido. That looks so horrible. Okay. Anything else? Yes.
Oh, the methyl group.
7.
Methyl. Wait, hold on. 7 methyl. Okay. Yes. That's true. You're correct. So remember I said about that line, right? Earlier. So this is bonded to the bromo, right? So then it should be
8.
8. Oops. It should be 8 bromo, and it should be octene. Right? Okay. So, and it's funny because we just talked about it, right? Like, this is what students always do. And then we just did that, right? And yes. No, the key is that you don't get it wrong, right? You guys are supposed to be better than me. You're getting to the point to be better than me. Right? I know, but you can still make it, they caught it. And it's training. What's up? That's right. Exactly. Yes, because I just talked to you about it.
Dr. Henry, I had a question, or
Yes.
just clarification. So
Yes.
when it's carbon, like at 7,
Uh-huh.
we stick to the methyl or the ethyl or those prefixes.
Yes. So
But when it's other elements, then that's when we use the actual element name.
that's right. Yep,
Okay.
that is correct. Good question. Or you use, because there are going to be other functional groups that have specific names, or you use their specific name for that functional group. We'll talk about that here in a second. Okay.
Okay.
Okay, questions?
And these are alkyl
Halides. Yep,
True. Okay.
alkyl halides. That's right. Okay. Do you want to do one more? Or you guys got it?
One more, please.
Okay, so let's see. That's right. So the one that has the most, we're going to try to kill as many birds with one stone as we can, right? Give it the lowest number possible. So we're going to start counting from here. Okay, so that's 1, that's 2, that's 3, that's 4, and that's 5. Okay, so then the name of the structure would be called
Pentane. Cyclopentane.
cyclohexane. Okay. 1, 1. Is it di? But how many are there? But aren't there 3? There's 1, 2, 3. Aren't there 3?
I'd say 1.
So it'll be trichloro. So it'll be 1, 1, 2, 2 trichloro.
Mm.
Yep, no, they don't have to be attached. That's right, because you don't want to put things redundantly, right? Because the key is to try to make the name as short as possible, but if you're saying, oh, 1 and 1, that's die, and then I have another one, that's too many, right? So we just try to compact it, because otherwise the names would be like, I mean, they're already long enough as it is. Could you imagine if we did it that way? Because there'll be structures that have, for instance, lauric acid. So lauric acid is a long carbon chain. So often there'll be branches that'll come off of it. And so you'd say like, you'll have 8 different branches. And so it'll be like 8, so octa, so 117722, whatever, octa chlorate, right? And then it would take us forever to sit there and write it down. So you want to try to consolidate it. So you're counting every structure that's exactly the same, and you're keeping track of it. Yeah. Does that make sense? Okay, questions, concerns, cash. Okay, ready to move on? Okay. Oh, did I tell you guys that we have a bet? Or I'm sorry. Are you guys gamblers? You guys are gamblers? Well, I know you are. Yes. So, are you guys willing to make a bet? They looked at me. Yeah. Okay. So here's my wager. Right. I said that, and I said this at Harnell this weekend. Any class that gets their average above 70%, I will buy you guys pizza since it's in the evening. Right. Okay. You don't like that? You don't like that bet? We're that picky now, huh? Okay, I see how it is. Fine, Dana. I was gonna get fatties because but I said fatties. Hey, is that acceptable? Okay, I just need to make sure. Little Caesars. Okay. Okay. So, however, if you guys don't get above 70, you owe me and the TAs pizza. That's the wager, right? Okay, so it sounds like a good wager. Okay. Oh no. So you guys want to compete with the other schools? Is that what you're saying, right? Don't worry about it. I'll get a little wager going on with that. So, but for the TAs, since I technically have TAs at every campus that I work, so the TAs at the end of the semester, they get a bonus. They'll get a bonus at the end of the semester. So if their class scores the highest of all my classes, their average is the highest at the end. So you guys got some work to do. So right now, Fireball has the highest average right now in terms of your test grades, your test scores. Yeah. Well, they were just under. Yeah. So it was like 67. They were just under. But you guys are like at 63. Okay. So you guys got some work to do. Right. And okay. So that aside, let's keep talking. So let's talk about these physical properties. So the things that we know about this, right? Because they're all, so far we've only talked about hydrocarbons primarily, except for the alkaline halides. So since we've talked about hydrocarbons, we know that things that have hydrogen and carbon in it are going to be polar or non-polar.
Polar.
Are you sure? It says non-polar on the slide behind me, right? So, but you guys should also know that because you've already studied this, right? We've talked about the bond between carbon and hydrogen. One is 2.2, the other one is 2.6. It's 0.04, and we know that that is going to be non-polar. So all of those bonds are non-polar, right? So if we know it's non-polar, that means that they're sharing evenly, okay? Now, since they're sharing evenly, it's kind of like, have you guys ever played? Oh, yes, I'm really digging it. Pong? Where the ball goes ding, 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 ding. Okay. Okay. So if we think about the electron is doing that, right? It's going between one atom and the other atom. So it's going from carbon to hydrogen, carbon to hydrogen, carbon to hydrogen. And it's being shared evenly, right? So they get it about the same time. They get it. So it goes boom, 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 back and forth, right? So if this molecule here, right? This molecule here is going boom, 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 boom. And then I have this molecule doing the opposite. So when this guy is over here, when the electron is here, the one is over here, right? And so they're going opposite. So this is going, if the electron is here, it's negative. If it's over here, this side is positive, right? So negative, then this becomes negative, and this becomes negative. This is going to be just the opposite. So for a brief moment, there's going to be that attraction because this guy's going to have positive when this guy has negative. And so they're going to interact. So those interactions between two molecules, is called intermolecular forces. Do you guys know what the interstate is? I-5, interstate, right? So it starts down south, right? And it goes all the way up to, no, it goes beyond that. It goes to Washington or Oregon. Which one is ever higher? Yeah, yeah. Okay, so it goes all the way up. So interstate means between states, right? Interstates, right? So intermolecular is between molecules. So because these guys are interacting between molecules, right? The longer the structure is, the more interactions you can have, right? And so they're really weak interactions, but the longer they are. So remember when we showed that table where we have things that are gas, right? And then liquid. So the ones that are liquid, they have more interactions. And so they're sticking together more. And so that's the reason why they're in the liquid form. Where the ones that are gas, they're smaller, right? They don't have as much to interact with. And so they're in the gaseous state. So they're not interacting with each other as much. So a liquid is going to interact more, so the longer we get, we become liquid. And if we get so long, like super long, it becomes solids. So like I talked about laurate. Laurate is a really long chain. We're talking about like 100 carbons that are connected or something like that, right? So that's a shit long of a chain, right? And so they're solid because they have so many interactions that are holding them together between each of those molecules. Does that make sense to you guys? Okay. So that basically means that the larger the molecules, the higher your melting point is going to be, the higher your boiling point is going to be. So the bigger you are, it's going to take a lot more energy to get you to break up because you have many more points of interactions than you would have in the case if you're a small one. Okay. So we also know that most alkanes are fuels, right? Because we talked about octane gas, propane we use to sit there and grill our gas, so butane, yeah. Okay, so we've talked about cycloalkanes, right? You know the structure. So they can only be formed with at least 3 carbon atoms. Now the thing is that when it is 3 carbon atoms, that molecule is so unstable. So cyclopropane is a very unstable molecule because of the angle. So do you guys remember VSEPR, the VSEPR theory?
Mm-hmm.
What does VSEPR mean?
Valence electron.
Well, that's that is what each of the one. It's valence electron, yeah. Electron pair.
A repulsion.
Repulsion, yes. So what does that mean? What does it mean? What was that? Okay, so that's right. So VSEPR basically means that the electrons pairs are going to try to get as far away from each other as possible. So that also means atoms. Atoms are going to try to be as far away from each other as possible. So in this case, this angle here is what? 60, right? Because if a circle is 360, right? So then, I mean, and then, so this one has to be, sorry, this is gonna have to be 60, this is gonna be 60, this is gonna be 60, since there's 3 points, right? To a triangle, so 180 and this, okay? So in that case, these guys are not gonna be stable. They're trying to push away from each other, right? They wanna get to at least 109. 109 is like the perfect one. It could be a little bit less than 109, but that's it, you know, just a little bit. These guys are at 60. Like, hell no, that's not gonna work. You're too close to me, right? So in this case, this guy would be way too close. This guy's gonna be way too close to this guy. They're not gonna like it, okay? And that's the same thing here where it's 90, right? Too close. So they need at least be 109.5 away from each other to be happy, okay? So these guys are not gonna be stable molecules. They're gonna exist, but they're gonna wanna react almost immediately, right? Because they're unstable, okay?
Okay, so is that like it would just like catch fire or something? Is that
Yeah,
what?
yeah. So in that case, they would be more reactive. They're going to be, because they're unstable, right? So they're going to be more likely to catch fire. They're going to be more likely to cause explosions and things like that because they're not.
Okay, or like if you dropped it, it would. Yeah. Okay.
Something along those lines. Yeah. So they're not going to be stable molecules. So and they're not going to stay in that state that long. Okay. Okay, we've talked about how you would go about naming it, right? So we want to try to give the lowest number to that. And if we can do a twofer, we always want to do a twofer, right? We've talked about unsaturated hydrocarbons. Saturated basically means they're all single bonds. Unsaturated means that we have at least double bonds. So that's our alkenes and our alkynes, right? We talked about how to go about naming those guys, its nomenclature. Now, this here is its common name suffix, and this is its IUPAC name. IUPAC, let me type that out so you guys see it and it'll stick in your head. IUPAC. So the E and E is this IUPAC suffix. So YL E and E is its common suffix. So, and for alkynes, yeah, its common suffix is the acetylene, acetylene. So, okay.
Wait, I have a question.
Yes.
Why is acetylene the exception for alkynes?
It's okay. It's called acetylene. Well, because again, it was its common name, and that was the name that was given to it before it became the IUPAC nomenclature. So this name is its common name, and so you kind of use that as a root when you're naming anything that has a triple bond in it.
Mm-hmm.
So when you're using the common name nomenclature.
Okay.
You guys remember? So my organic chemistry class, they actually have to learn both the common name and the IUPAC name. You guys, again, are focusing primarily on the IUPAC name. If you know the common name, that's great, but you want to definitely know the IUPAC name. So here, this is basically showing you. So it's showing you the alkenes and the alkynes. So this guy is called ethylene, propene, butene. Okay. So, and these are the common names, right?
Mm.
So we've talked about isomers, right? So there are also what we call geometric isomers, right? So in this case, these guys are, this is butene. This is 1-butene. This here is called cis-2-butene. So cis basically means that they're on the same side. So if we have like a football goal post, right? So this here represents the double bond, my thumbs. And then the carbons are going to be on the same side. So that would be cis. Trans would be like this, where they're opposite of each other. So currently we use the term for gender. right? Cisgender, right? That basically means that your gender matches the gender that you had at birth, right? That would be cisgender. Transgender means that you're changing from your birth gender, right? So across, trans. Okay, so cis, same side, trans, across. You guys see that? Yes, so the key to this is that they're different. They have different chemical properties. They behave differently because of these structures. And that's the most important part of this is that, you know, even though they have the same chemical formula, right, their shapes, the fact that they're cis or trans is going to cause them to behave differently. Okay, so they're going to be more reactive in one case and less reactive in the other. They're going to have different melting points. They're going to have different boiling points because of that. Okay. So when we talk about a single bond is able to rotate. So you guys remember when we had the model structures? I didn't get to let you guys play with it enough. But if we had the model structure, we have the model structure. You have it? It's right next to me. Where? Oh, right here. Okay, so this guy can actually rotate, right? So this atom here rotates and everything like that, right? So we're able to sit there, rotate, and if there is a connection between, I don't have it, I wish I did. So if there is another connection here, these guys would be able to rotate with each other, like what we see here. Okay, so this guy's able to sit there, rotate, this is able to rotate the other way. Okay, and so often what happens, it rotates till it finds the lowest energy level, because again, we don't like using a lot of energy. We want to try to be stable as possible. So it'll rotate till it finds the lowest energy level, and then it'll kind of sit in that position, try to stay in that position. The double bond can't rotate. It's fixed because there's two bonds right there, right? So it's not going to be able to rotate. Triple bond definitely can't rotate, okay? So they're kind of stuck the way they are, okay? So here, this here shows us cis and trans again, but it shows it a lot clearer, right? So here, this guy is cis 1,2 dichromoethylene. Here, double bond, and then these guys are going to be cis to each other on the same side. Where this guy opposite to each other, right? So, aromatic hydrocarbons. What do you think aromatic means? Scent, it smells. So often what we represent aromatic about is pleasant smells, right? Aroma. Oh, I love the aroma. You never say that's a shitty aroma, right? You usually say it's a no, it's always something positive, right? Okay. So a lot of our scents are a result of hydrocarbons, and they're a result of a specific type of hydrocarbon. Like for instance, these guys made banana extract or banana oil. And so they made it synthetically, right? Totally synthetically made. It smells just like bananas, right? So when I was in school, we made strawberry oil, and it smelled just like strawberry. It was bomb. It made me want to eat it, but no, I didn't, because I knew exactly what I put in, and I'm like, I'm not eating that, and I didn't. At that point, definitely did not trust myself. So the simplest aromatic hydrocarbon is benzene. Benzene is a 6-carbon structure, and it has double bonds alternating in that ring structure, okay? And it's a ring structure, so those double bonds are alternating. So often, we will draw benzene with the 6-carbon ring structure and put a little O in it, because we know that, you guys remember resonance structures where the electrons are basically moving, right? So in this case, the electrons are going to be moving from here to here. So when these electrons move, these electrons are also going to move, and these electrons are also going to move. So they're just going to be shifting from each other. And so we just draw it simply like this to let us know that that's the benzene ring. So benzene ring is responsible for most pleasant smells that we have, right? So, you know, your perfumes and stuff like that you get from Bath and Body Works. So a lot of those start with the benzene ring. So it'll be modifications to the benzene ring that gives us those different smells. Okay. So aromatic hydrocarbons have a benzene ring, right? And they're going to start off with that benzene ring. Emphatic hydrocarbons are what we've talked about prior. So those are going to be your long individual chains, or they're going to be simple ring structures, but that don't have 3 double bonds in them that are alternating. Okay. And these guys are also going to be nonpolar in most cases, and they're going to be insoluble in polar solutions. So like they're going to be insoluble in water. So often we'll have to put them in oil to kind of get them to resuspend. Okay. You guys have your banana oil? Maybe you should. What was that? Okay. So when we go about naming these structures, these aromatic structures, it's going to be the same process. The only thing, instead of saying cyclo whatever, we say benzene, right? So for instance, if we have a methyl group, so we would say methyl benzene. We don't have to put one because it's understood to be one, because there's only one present. Here, this guy would be bromo benzene. Okay. Now, methyl benzene has a common name associated with it as well, called toluene. Toluene has a very nice smell associated with it. So this guy 1,2-dibromobenzene. This is its IUPAC name. Its common name is called O-dibromobenzene. It's called O because the bromine is right next to it, right? So since it's right next to it, we put an O there for its common. Okay. So IUPAC is a lot easier to remember. You don't have to remember, okay, is it next to it or is it across from it? Or okay. So you just put the number. So this guy's called 1,3-dibromobenzene. Or its common name would be M. M stands for meta. So basically you have one spot between it, right? And so that's what that meta stands for, having that one spot. And then if it's right across this, we would put a P. So in the case of 1,4-dibromobenzene, we would call this guy P-dibromobenzene. That means para, across from each other. Okay. So ortho, meta, para. O stands for ortho. So here's the structure. If the next structure is right next to it, it's called ortho. If the structure is one away, then it's called meta. If it's across, it's called para. Does it still have the smell? Yeah. So yeah, go ahead and pass it around so they can get a whiff of your banana. So just kind of. He's got to be a little closer. Yeah. You just kind of, yeah. Don't snort it. Just take a whiff of it.
Wait, is that an ester? Or is that something completely different?
No, esters are different. Don't worry about it. We will talk. Well, we won't talk about esters in this class. We'll talk about ethers. Now, esters are different. Now, esters have another type of smell, but it's not often considered aromatic, and their structure is going to be quite different. Okay. Good question.
Are we going to talk about alcohol?
Yeah, of course we're going to talk about alcohol. You know, everybody likes turning up, right? Oh, I'm sorry, wrong class. You guys aren't even awake, so how can you turn up if you aren't awake? Okay, so some of the physical properties of benzene. So benzenes, again, are going to be nonpolar. They're going to be insoluble in polar solvents. They're going to be soluble in nonpolar solvents. So Non-polar solvents are like in oils and things like that. And they're going to be liquids at room temperature. So the other thing about aliphatic hydrocarbons, you guys ready? Come on. Back here. The allophonic hydrocarbons, they're often associated with fats and oils. And so initially that's where the only thing that they were associated with were fats and oils, aliphatic. Okay, so it just basically means that it's going to be lacking the benzene ring, right? Aliphatic. And the way I remember aliphat, fat, oil, okay. So, okay, so these are some of the things that you want to keep in mind. So the aliphatic open chain, so these are the alkanes, the alkenes, and the alkynes. These guys, alkanes, are going to be saturated. Alkenes and alkynes are unsaturated. Aliphatic cyclohexane chains, these guys are cycloalkanes. These guys are going to be unsaturated. And the aromatic ring is going to be unsaturated. Sorry, this is going to be saturated. This guy's going to be unsaturated.
And unsaturated, that means
Unsaturated means that it's only single bonds there. So that's what it actually means. It also means just saturated with hydrogen. It's so much hydrogen that there are only single bonds there. Okay. So anything that only has single bonds only is going to be saturated. Things that have double bonds or triple bonds are going to be unsaturated. So when we talk about saturated fats are all single bonds, fats that only have single bonds, where unsaturated fats will have double bonds and triple bonds. Okay. So alcohols. We're going to start off with alcohol. So how many of you guys turn up? How many of you guys are old enough to drink?
me.
I don't believe you guys. Some of you guys are like, there's no way they drink. No. No. How many of you guys, I should say, how many of you guys drink first? Yeah, we're being honest. We're being honest. How many of you guys are old enough to drink? Okay. It's good to know. Good to know, right? Okay, so let's talk about alcohol since we know that alcohol. So drinking alcohol is ethanol. Eth means what again? Two.
2 bonds.
So there's 2 carbons. Five hydrogens and an OH group. So technically 6 hydrogens. But it's often written like this because we want to single out that OH group, right? To let us know that it's an alcohol, okay? The way that the structure looks, we know that it's 2 carbons.
Is that a 5 or
That's a 5.
okay?
Okay. So 1, 2 carbons and an OH. Okay. So the OH or the hydroxyl group is our functional group for alcohols. So alcohols have priority because most chemists are alcoholics, have priorities in terms of the functional groups. So if we talked about our functional group so far, we've talked about at the bottom. Who's at the bottom? Do you guys remember? Get there. Not the alkynes. It's, what was it?
Alkali.
Achial.
Halides.
Halides, that's right. Then above that would be
Alkane.
alkanes. And then above that,
Alkene/alkyne.
alkene slash in terms of priority. In terms of the ones on top have more higher priority than the ones on bottom. Okay, and then above those are alcohol. Okay, so alcohol has higher priorities than the double and the triple bond. So that basically means that we end the name with OL for alcohol. So we call this guy ethanol. Okay. So if it's at the very end of the structure, we just call it whatever the carbon chain is, and then we put OL. We don't have to put a number. Okay. But oops, sorry. Let's say we have we don't have to put a number because we understand that it's at the end of the structure, right? So because it has priority. So this here is going to be our first carbon, that's going to be our second carbon. So it's always going to be at the first carbon if it doesn't have a number there, right? But if it's not at the first carbon, like this case,
Is that what
then
you're,
we have to put a number, right? So what would this guy be called? Longest carbon chain.
for?
So it's
One,
1,
2,
2,
3.
3, 4, 5. 5 carbon chain. Penta. Okay.
Pentane.
Chain. And then we know that there's an OH. So we put OL. And then we have to say where it's at. Where is it located at?
2.
So it'll be 2 pentanol. Okay. Okay, what if we have something like this? Okay.
One dash or hexanol.
Would it be cyclo?
Oh yeah, cyclo. Yeah, definitely cyclo.
So this guy would just be cyclohexanol. Okay.
So we wouldn't have to put where the branch is?
Nope. Because it's always understood to be at the 1 if you're just putting cyclohexanol.
Okay.
At the 1, the first carbon, if you just put cyclohexanol. Okay. Let's make it a little more challenging.
Would it,
Okay. And remember, since it has priority, we want to try to give it the lowest number. So am I going to count from the left or the right?
The right.
Okay. So 1, 2, 3, 4, 5, 6. Okay. So what would be the name of this guy? So
Would it be 5-methyl 3-hexanol?
5-methyl. Okay, so what was it? Is it hexanol? But there's a double bond here. And where's that double bond located at?
3.
At the 3. So in this case, since we have 2 major things in the structure, the all gets the last name, but the ene has to be included as well. So we put hexa 3 ene dash 3 all. That's right. Everything has to be location. Location for everything has to be located.
So since they're looking at same one, right?
Yep.
So if you change one of them to 4, like one of them's okay at 4.
Yes.
You still write same though?
Yeah, but you just put 4. Yeah.
Okay.
Yeah. Okay. Since they're both starting at the 3 carbon, so in this case it would be at 3. Well, let's say we have if we had the OH at the 4th, then we try to make that the smallest chain, right? So that'll be 1, 2, 3 for OH, and then it ended up being the same thing anyway. So yeah, in this case, it ended up being the same thing.
So the alcohol or the ene and all, that's only for if there's an alkene or an alkyne and alcohol. But the alcohol always overtakes the alkane.
That's right, because it has priority. So the question is, can you guys see that in the back?
Who has priority?
Okay, so the question is in terms of priority, since alcohol has higher priority, it has the last name. Again, it's kind of like we are a patriarchal system, right? So patriarchal system means that, what does patriarchal mean?
Father.
It's a quote male-led system, right? Since we are a patriarchal system, whether we like it or not, we end up when women get married, they take on the man's last name, right? Is that true? Right? So because we are a male system, so it's based upon priority, right? So you're saying by doing that, saying that the man has priority because we're taking on the last name. So the one that has the most priority is the alcohol, right? So then we take on the alcohol's last name, OL. Okay. I don't throw darts at me. I'm just telling you how it works. It's based upon priority, right? Are you guys with me? Any questions? Because you guys, I'm getting like weird vibes. I'm like, okay, I get it, but I don't get it. Is that what I'm getting?
I have a question about the spelling
Okay.
for the double bond.
Yes.
Is it EN or should it be ENE?
Okay, so that is a very good question. It's typically EN. However, certain textbooks will leave the E there. Technically, the E should be dropped. It should just be EN because it's that ENE means it's the end of the last name, right? By putting the EN, you're saying it's not the priority.
Okay. Will we be docked for
No,
putting?
you won't be docked for it. I will let it go because depending on the textbook that you learn from, they use both. But official IUPAC, it should be dropped EN.
Okay.
Yes, there is another way to write it. So you could have put the 3 in front and then put hexene. So let me show you the other way. So but I recommend that you do it this way because it makes it easier. Okay, so this 3 refers to the ene, where that ene is at. And then this tells me where the alcohol is at. Okay. So, but since you have both items in the main structure, it's easier to see it this way. Okay, questions? Concerns? Okay, good. Okay, so those are alcohols. Are you guys feeling okay? Want to try one more, or do you guys want to move on?
One more.
One more? Can I erase this part here, at least?
Yes.
I need room to write. Okay, so let's try. Let's do this. Okay. Let me move my head out the way.
So would it be the longest chain 9,
Okay, where are we going to start counting from first?
where the OH is?
By the OH. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9. Okay,
Mhm. So that would be Nona, but there's a triple, so it'd be no 9.
it will be no 9. Are you sure? So there's a triple. There is a triple,
Mhm.
but there's 2 triples. So how would I signify 2 triples? Di, but what do I have to put in front of it? I have to put numbers in front of it. Okay. So where are they? 5 and 7. So it's 5, comma 7. And then you said di, ein. Okay. One.
Oh.
All. Okay. And so we'd have 3 bromo. Horrible, right? So if you look on the back of your shampoo bottle, I won't say this one is there, but you'll see things are very similar in terms of its nomenclature. Okay, Questions? Heidi, you have that look. Nona, for 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right. The alcohol all is at the very end. That's right. And then the di, because there's 2 double bonds. There's one at the 5 and there's one at the 7. So 5, 7, di, y, n. Di meaning 2, yn meaning triple bonds. Yeah. That's right. That's right. Yeah. Yeah. Does that make sense? Brandon? Yeah. Sort of? Okay. Okay, so you ready to talk about ethers? Ethers are a little bit easier. So I'm going to teach you the common name. The common name is used more than an IUPAC name, and I will also teach you the IUPAC name. Both. If you can do either one, you'll get credit. Can I race? Okay, so ethers technically are below alcohols in terms of priority. Okay, so an ether is a hydrocarbon that has an oxygen between itself and another hydrocarbon. Okay, so the way you would name this guy is that you would count the carbons on each side, starting the one nearest to the oxygen. So this is 1, 2, 3, and then on the other side, this guy has only 1. Okay, so then we say, oh, this guy, its common name is methyl propyl ether. This side is the methyl, a 3-chain carbon is propyl, and then the fact that there's an oxygen there makes it an ether. Okay, so that is its common name. And it is the most commonly used name for ethers. Its IUPAC name is the longest chain gets the last name, and then the other part gets oxy added to the end. So this guy is called methyl oxy propane, or methoxy propane.
Can we do the common name or do we do the IUPAC name?
Either one in this case is fine. Okay, so either one is okay for the IUPAC name. They started shortening, getting rid of the YUL and just putting methoxy. So a lot of your shampoo bottles have methoxy, whatever it is, and so.
So in order to separate the one side between the other, we put in oxy for oxygen.
That's right. Exactly. We use oxy for oxygen. Yep.
And then in order to name it, we still follow the alphabetical order.
That's right. Well, no, in this case, you're not following alphabetical order. It's the longest chain. Longest chain gets the last name.
Longest chain gets the last name. Okay.
So if this was a hexene on this side, then it would be called methoxyhexene. Okay. Okay. You guys with me?
Mhm.
Got 4 more slides. Okay, so I'm going to clear, and then can I erase this, and then we'll give you guys a trial run. Everybody got it down? Okay. So. Okay, common name would be what? I said the common name would be what? So that's 1, 2, 1, 2. 2 carbon on both sides.
Mhm.
Diethyl. Diethyl what? You put at the end.
Ether.
Ether. Diethyl ether. Okay, it's IUPAC name. F oxy. Oops. Ethane. Not in this case, because it's the long chain gets the last name, and then the other part gets the oxy added on, or the ethyl oxy ether or ethoxy ether. Okay, because one side is ethyl, the other side is also an ethyl, right? Ether, ethane, 1, 2, 1, 2, right? Both of them have 2 carbons on both sides.
Mhm.
Okay, so ethyl oxy ethane or ethoxy ethane. Okay, so either one is fine. You guys okay? So what is it confusing about it?
So it's oxy for the.
For oxygen, yes. So you're just saying that there's an oxygen between the hydrocarbons. So on this side, this is ethyl, oxygen, ethane, right? So, and usually it's just the one that has the longest carbon gets the last name, right? So let me give you another example. Let's say we have this guy. Okay, what would that be called? Talk today. Carbon chain, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this side is just 1. Okay, so then if we're doing the IUPAC name,
Oxy, no name.
you said methoxy,
Yeah.
no name. Right? This side, smallest carbon chain, right? So that gets the front part. Meth, then there's an oxygen, and then it's a no name. Got it? Okay. Did everybody get it down? Okay, good. So let me give you some examples. So this guy, this is the red represents oxygen, the white represents hydrogen. So this guy has a hydroxyl group. So we know that these are alcohols, right? So this guy has 1 carbon, ethanol. This guy has 1, 2, 3, 4 carbons, and an OH, 4 carbons, butanol, right? These guys, 1, 2, 1, 2, and an oxygen in between both of them. So diethyl ether, or as we said earlier, ethyl oxy ethane. So this guy is a benzene ring. So when a benzene ring is in the prefix, or when it's before, right, it's not a priority, then it's called phenyl. Okay, so this guy is called methyl phenyl ether. Or we would call this guy methoxy benzene. That would be its, because this is the benzene ring, right? That would be its IUPAC name. Okay. So last one, and then we'll put up some, and then as soon as you guys finish it, you guys can take off. We'll put you guys in groups, and the group that finishes can leave. Okay. Okay, so the last one is carboxylic acids. So carboxylic acids are going to have this C. I know you guys can't see it. That COOH. Now the structure for the COOH is this. I hate this thing. Yeah. Actually, let me do it like this. So it's a C double bonded to an O. And it's also bonded to an OH. Okay, so if we have another C here, this is 1, 2 carbons. So 2 carbons, I would use what? Or 2 carbons? F. Okay, so this guy would be called ethane, so ethyloic acid. Okay, so for carboxylic acids, This guy is called ethanoic acid. So it's oic acid is going to be what we add on. Okay, so anytime that you see a C double bonded to an O and an OH, we know that it's a carboxylic acid. So then you just count the number of carbons, 1, 2, and then you would give it its name. So this guy would be called ethanoic acid. Okay, its common name is called acetic acid.
Oh, vinegar.
That's right. So this is the chemical structure for vinegar. And this is the IUPAC. Okay. So let me show you what it looks like in terms of the stick structure or the skeletal structure. Okay. So that's what it's going to look like in terms of its skeletal structure. Okay. So let's say I have this guy.
In regards to the names, which form is used more in industry?
The IUPAC is starting to be used more. So the problem is that we have a lot of old scientists that still use the common name, and they teach their students the common name. And so, scientists basically die in the lab. They'll be 90 and they're still teaching. That's typically the trend, and literally die in the lab. And so, but IUPAC is starting to get more and more cool. And so we're starting to get used to it. But when you look at it, you can search either the common name or the IUPAC name, and you'll find it, if you're looking at the chemical. And most chemicals will have both the common name and the IUPAC name. Eventually, that's the goal, is to eventually just use IUPAC, because it makes things very systematic, rather than on a wheel. I'm just going to call this acetylene, or,
Right.
it's a little more, as I said, systematic. Yeah. Okay, so first thing I'm going to do is to do what?
Count the carbons.
Count the carbons, and we're going to start where the double bond is attached to. So that's 1, that's 2, that's 3, that's 4, and that's 5. Okay, so I forgot to say that carboxylic acids are the highest priority of the functional groups that we've talked about. So these guys are above alcohols. Stop picking at your eye. Okay, so 5 carbon chain.
Would it be pentanic acid? Pentanic acid?
Ethanoic acid. Okay, piece of cake. Okay, and so we can also add, structures off of it, and so that's going to change the name. So if we put a bromine here, so then it'll be 4-bromo-pentanoic acid. Okay. Okay, so now these are all going to be weak acids. So weak acids basically don't dissociate completely. They kind of stay together a little bit, right? So they don't get rid of that H plus, kind of keep it a little bit. Okay, so they're going to ionize, but not so much. In terms of conducting electricity, they're going to be really weak at conducting electricity. Okay, so here's examples. So this guy is called formic acid. That's its common name. let me clear this. Common name, formic acid. This guy is acetic acid, and this guy is propanoic acid. Yes, and so that is its IUPAC name. So what would be the IUPAC for formic acid? It has 1 carbon.
Methyl,
Methanoic
methanoic.
acid. That's right. That's its IUPAC. And we already know this one. We just did it. That was ethanoic acid. Okay. Questions? Concerns? Cash? Excellent. So let me pull something up. And then we'll put you guys in groups. This is a group here. That's a group there. And that's a group there. And you guys online, you guys are a group. So let me pull up the figure. Sure. Can you guys see that?
Yes.
Okay, so these are your 10 structures. So you need, as I said, you need to be able to go both ways. So from 1 to 5, name the structure. From 6 to 10, write the structure. Draw the structure. Skeletal structure.
I agree.
Okay, so let's start off with 1. Are you guys, you want a little help? See if you guys are on the right track.
Us?
Yeah, well,
Sure.
I'm talking to everybody here. So
Well, we were stuck on 3.
on 3, okay, we'll go over it in just a second. Okay, so
Okay.
let's do the first one. Okay, so we have 1, 2, 3, 4. Let me write it down. So that's 1, 2, 3, 4, 5, 6. So we can name this guy. There's 2 ways that you can name this guy. So there's one way would be
Hexa.
hexane, right? So, but we have to say where the hexane is at. It starts at the 4th carbon. So we want to put 4. So you always want to put where the double bond or the triple bond starts. Okay. And then we know that it's an alcohol because it has OH. So we put where the OH is at 3 and OL. So that's one way of doing it. The other way of doing it is hexa 4 ene or ene dash 3 dash ol. Okay.
Mhm.
So either one of those are fine. Did you guys get that? Can you see it? Okay, so this guy here, I'm gonna draw and write at the same time here. So this guy here, we know that this guy is a carboxylic acid. So it's gonna have an IC associated with it. How many carbons do we have? That's 1, 2, 3, 4. We always start counting at that first carbon that's attached to the double bond. So a 4-chain carbon,
Butanoic.
butanoic,
Butanoic acid.
butanoic acid. Okay,
And then
so is there anything else that's there?
a branch
There's a methyl. There we go. And it's 3-methyl. 3-methyl butanoic acid. Okay, number 4. So we know that this guy is a benzene ring, right? So it has 1, 2, right? So do we want to start counting here or do we want to start counting here? We want to start where there's 2 things at, right? because we get a twofer, right? So then we call this guy. Let's start counting here. So that's 1, 2, 3, 4, 5, 6. So since it has that 6 ring structure with that circle in it, it's benzene. So this guy would be called one, 2, di, bromo, one methyl, benzene. Okay, so this guy, what are we going to do first?
Count the longest chain.
Count the
Or
longest chain.
like starting nearest to the
Here's to the O. That's right. 2, 3. And then over here, it's 1, 2. Okay, so then what would this guy be called? So you said what? Ethoxy, propyl, or propane, right? Not propyl, right? Ethoxy propane. So that's one way of naming it, true. The other way is ethyl propyl ether. And the other way would be ethyl oxy propane. There you go. It's a tricky one. Okay, what am I going to do? Where am I going to start? Left or right?
left.
Okay. More bang for my buck. Okay, so that's 1, that's 2, that's 3. 3. This is 4, 5, 6, 7, 8, 9, 10. Okay. So a 10 chain carbon,
Decking,
Deca?
decyne, or yeah, deck.
Okay, so we got deca. Okay,
And then ine for the triple bonds.
so we got a triple bond. So you're saying, but how do I say, but I have more than one triple bond, don't I? How many do I have?
1,
I have
2,
3 triple bonds. So how would I say tri? Okay,
Tri,
so
yeah.
deca, tri, triene. Okay, I have to say where it's at. Where are they located?
1, 2,
1,
5, 9, 10.
1, 4, and 9. We only start where they start at. We only put where they start at. So it's 1, 4, and 9. Okay. Anything else? Oh, we have some methyls too, right?
Right. So it's like a what? 3.
Methyl.
We got
Would it be 3, 6 trimethyl?
So 3, 6, 6. We want to say where each one of them is at. Trimethyl. Trimethyl.
You have to repeat the 6 because you just can't.
That's right. You do have to repeat the 6 because you want to make sure that people know exactly where it's located at. So if there's 3, you have to give me 3 numbers. If there's 6, then you have to give me 6 numbers, right? Okay, does that make sense?
Yes.
Nope. The 6 is a methyl because it's a branch and a branch. Ethyl means that it would be connected. It has to be connected to each other. Okay, so there's 2 independent branches that are coming off of the 6 carbon. Okay, structure. I always like starting off with the last part because then I just put everything else on there, right? So cyclohexane. What does cyclohexane look like?
A circle with 6 carbons.
6 carbon in a circle, right? Or a hexagon, right? Okay, so on the first carbon, there should be a what? Because it's 1 cyclohexanol, an OH. That's right. So there should be an OH. Isn't that what you said? Or am I just putting words in your mouth? Okay, so that's 1. So if this is 2, what's on the second carbon? So that's 1, 2. So that's my branch. And then on the third carbon, a branch.
2 branches with bromine.
2 branches of bromine.
Now, is the bromine always like bond? They're always connected to the carbon. It's not like a bromine's connected to another bromine.
That's right. The bromines are connected to the carbon.
Okay.
Anytime that if you had something else connected to something else, they would put it in parentheses, and then they would have that attached to that parenthesis. Okay, but right now you don't have to worry about that. I'm going to keep it simple. Okay, so pentanoic acid, penta,
5.
5. And then we know on that carbon there should be a double bond.
With oxygen.
Double bond with an oxygen. And then, oops. Then we have an OH coming off the other side. So that's 1, 2, 3, 4, 5. Okay. Yeah. Yeah, you could have started on this side with the OH, or you could add it on top, it's fine either way. Yeah. Okay. So this guy
You would start at the end, so propane would
Okay,
be
so
3,
propane is how many carbons?
3.
Um,
Okay, 3 carbons. And then what is the OL for?
Oh, for 08.
OH. Okay, so if this is going to be my 1 carbon, so then I'll put an OH here. And then what's off of the second carbon?
A branch.
Just a branch. Okay. Methyl, nonal, ether. What is that going to look like?
It's going to have an oxygen in the middle
So we're going to have an oxygen in the middle.
and 9 carbons.
That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9.
And on the other side, just
It doesn't matter if it's on the other side. And then what's on the other side?
1.
Just 1. 1. Okay. What about this guy? This one's kind of hard to do. Backwards. It wasn't hard to do? Okay.
So the longest chain would be 10.
So it's a 10 carbon chain. Okay. So but we know that we have a 3 and a 6. We have double bonds, right? So that's 1,
or
2.
that'd be 2 double bonds, right?
There's 2 double bonds, right? Okay. So I mean triple bonds, not double bonds. There's 1. So that's 1, 2. And then on the third carbon, we have a triple bond. Okay. So then triple bond. So that's 1, 2, 3, 4. And then we have 5. That's this guy. So 3, 4, 5. And we have another triple bond. Okay, 6. Okay. 7, 8. 9 and 10. Let's count it to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Anything else?
A bromine on 1.
Bromine on the first
carbon.
Okay.
So I have a question on that one.
Yep.
Is there can we do it another way than that? Like, can it be like the carbons just like in number 9?
Yeah, it doesn't have to be this kink that we have here. We could add a kink going down and
Yeah.
over, as long as you end up with 10 structures. And the other thing is that you want to be sure that your triple bond is linear, right? So, because it's going to be a linear structure.
Mhm.
Does that make sense?
Yes.
Okay. Questions? Oh, sorry. Roughly. So the best way of remembering the functional groups is flashcards, right? OH, put a little dash next to it, flip it over. Okay, so we know those are alcohols, so OL. So that is the best way of memorizing them. Take care. You got it?